It's the idea that you're following the exact same steps over and over and over again. It's kind of the boring math. Yes, we're a bit boring. But this stuff, if you replicate the process, it's a lot easier. Same thing with the one below it. You have 1/2 x plus 2. You're parallel through -2 and 4. Step 1, what's your slope? Is it a parallel slope or a perpendicular slope? Excuse me, it's parallel, so what's parallel to 1/2? Half. And lo and behold, it's back to point slope form. What's that? No. 13, yeah. The 13, yeah. Fill in the blanks. Y minus 4 is 1/2. Instead of writing minus and negative, what do we always put? Plus. Distribute out. Add 4. And there you go. Parallels. Perpendiculars, so if you had (1/2 x minus 5), and you wanted to be perpendicular through an ordered pair, they gave you 4 and 0. Again, the only difference is you have to do perpendicular slopes now. It means you have to do opposite reciprocals. It means change the sign, flip the fraction. Original slope is 1/2. What's the opposite reciprocal of 1/2? -2. Good. You have to put it over 1. Doesn't change anything. Just -2. Point slope. And fill in the blanks. Do I have to do anything with -0? Can I write y minus 0 if I wanted to? And it doesn't change anything. I just leave it off. Eat it. And just distribute and you're done. -2x plus 8. Okay. As you're doing these problems, guys, they're not meant to be super difficult. They're really not. The only ones that really weren't mixed in with these things were the ones where we had those quick, is it a vertical or a horizontal line, those types. And those are ones that you are going to screw up, but unfortunately the textbook doesn't seem to think that you need to know them. So for example, if you have the equation y equals -2, and I want you to be perpendicular through the ordered pair of 3 and 7, what's your equation? What kind of line is y equals a number? What kind of lines are perpendicular to horizontal lines? So you're saying horizontal lines are perpendicular to horizontal lines? So what kind of lines are perpendicular to horizontal lines? And what's the equation of every vertical line? What is x equal? Again, it's the idea that you have to remember that this is a horizontal line, and horizontal and vertical are perpendicular. Okay. And that's all you have to do. I know we didn't have many of those, but that's not what it shows up. Also, with the idea for today and into tomorrow, because I've said we will test on Thursday, not on Friday. We'll do it on Thursday. Friday we'll do something different. Excuse me. On today, what I want to do is just kind of go through all the equation stuff that we've done. what we've done here, if you think about it, over the past about 4 days, I think we started about last Thursday or so with the equations again. You go back thinking about your equations, we had slope, we had point slope, then we had slope-intercept form. We had those three forms. From there, we kind of mixed together using them depending upon what setup or style you were working with. Sometimes you were asked to write the equation of a line given a slope and an intercept. Sometimes you're asked to write the equation of a line given a point and a slope. Sometimes you're asked to write the equation of a line given a pair of points. Each one of those styles means you had to do or start something differently. Which meant you had to understand what you were given in the beginning to finish it out. For example, if I give you guys, if I say write the equation of the line, write equation of the line into slope-intercept form, with the following. Info. What would you have to do first for one like this? Find the slope. Very good. When you're given just two ordered pairs, the only thing that you can do is find the slope. Right? So what we do, and we've done this a bunch of times, you might want to write this down. What we do is, like I said, we've done this a bunch of times, especially if you forget how to do slopes and what points go where, what ordered pairs. It's not a bad idea just to take a second and actually label first X, first Y, second set. And by now, you've probably done slopes, I don't know, 100 times in your lifetime. Change in Y or the change in X. Well, 7 minus 4, 4 minus negative 3. If you couldn't figure that out, what could you use to help you? A calculator. Use a fraction bar on the calculator, it will do the work for you. You get 3 sevenths. Da, da, da. Okay. Now you have a point and a slope. Gee, what do you think you're going to use now? Point slope. Because then you can solve for y. Remember guys, it's kind of the same thing over and over and over again. Does it matter which setup you use, which point? Doesn't matter. Okay, so if we have y, we'll use the first set. Y minus 4 is 3 sevenths x plus 3. And why did I write it as plus 3? Again, don't freak out because you've got fractions. It's no big deal. Press the button in the calculator, multiply across, you'll be fine. Oops, sorry. Once again. Calculator will do that for you, and then what do you do with the 4? Good. You just add that over. Sevenths. Button will do it. It's 37 cents, right? I have a calculator, just use my brain. And you're done. No fractions or no decimals. No mixed numbers. Don't need them. Calculator does it. direction. It's okay. Nothing wrong. One of the other things that we didn't spend a ton of time on, this was mainly on Friday. We did graphing. Now, I know you guys don't have a sheet of graph paper in front of you, and that's fine. We don't need it for right now, because the problems we have tonight, you'll have some graph paper on there. What equation is that written as? What form? Y equals mx plus b. That's called what? Slope-intercept. Good. That's slope-intercept form. What's the slope? 3. What's the intercept? -1. Now, is that an x-intercept or a y-intercept? The -1. It's the y-intercept. The y-intercept, so let's go up and down or left and right? Up and down. Good. The y's always start on what we call the y-axis, the up and down. So I'd start this one at -1. Then I would walk my slope. Is the slope there positive or negative? Positive. So what's your first step? Up 3, then what direction? A minute. 1. So I go up 3, right 1, up 3, right 1. Remember how we did the up and right, same thing as down and left? And I'm going to ask that you guys fill in the dots that fit the entire graphic. Sometimes you'll get, in this case we got what, 5 of them on there, 6 of them? 7 actually. Sometimes we only get 3. Sometimes we only get 2, depending on what the slopes are, how the lines they match up. Okay, it's not a big deal. Now, what's different between this equation and one like this? What's different? What are you doing? What are you doing? You're right. You got to move the 2x over. What do you have to get by itself? Y. So sometimes you're given equations that aren't actually in slope-intercept form, and you have to solve for y. When you do that, that's something called a literal equation. You don't even need a term about this. So if you get something like this, where you have x's and y's on the same side, this just means solve for y. Get y by itself. Right? If I wanted to get y by itself, what do I have to do first? Yep, add the 2x over. Now, when I add 2x over, do I get 14x? No, what do I get? Okay, you're saying 12 plus 2x, but can I put 2x in front of the 12? And I will, because that way I'm putting it into that slope-intercept form. Okay, so you're going with that? So we get 4y is 2x plus 12. Now what do? Divide what by 4? Good, I'm glad you used that word. Everything. Every piece gets divided by 4 now. It's got to stay balanced for the equations. So what's 2 over 4? 1/2. What's 12 over 4? Could you graph that easily then? What we're worried about. It's the idea that you can take and solve what's called a literal equation, just getting y by itself. That's a very, very, very common thing. I actually have some examples for you guys this evening of that as well. Let's see, what else is there? Here we haven't done in a while. Oh, excuse me. That would be beyond. Let's say you just wanted to find slope. Or I know. Sorry. You want to write the equation of the slope-intercept form. You got the slope and the intercept. What's the equation? Okay, that was easy. Somebody, I mean, eventually you guys will all be in sequence by saying it at the same time, but you know, you're kind of in a round. You guys want to even by that in a round? You don't remember that? Row, row, row your boat gently down the stream. Merrily, merrily. You're supposed to keep going. Help me out here, ready? We're doing it. Yeah, we're gonna do it. So you guys will start row your boat and do it loudly, okay? Go. No, you did it wrong. You start over. All right, you start over. Ready? Here we go. Do you not know the words to the song? Help them out, would you? Please. All right, here we go again. Ready? You guys are doing great. Sounds awesome. You guys suck. All right, ready? Oh! Why not? Are you too cool for us? Do you want to start? Start. Ready? Ready? Here we go. Row your boat gently down the stream. Merrily, 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 life's but a dream. Again. Row, row, row your boat gently down the stream. Merrily, 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 life's but a dream. Row, row, row your boat. Come on! You guys have no fun. Your lives are going to be boring. They pay me not to be in choir. Then you get people like merrily, 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 merrily. You screwed it up too. Merrily, merrily. It's true. Not the rest of these yabos. T-H-A-T. You guys gotta spell that. Spell Yabo? Was it Y-A-B-O-W-S? I don't know. Sure. Yabos. So, what I did here, guys, is I've taken basically our chapters kind of into two different parts. One part deals with all the linear equations, and the other part was all the angle pair relations. So we've spent the last 4 days basically working on linear equations. So I figured we'll do some quick review stuff that I have for that tonight. And then if you get a chance to start on the angle stuff, that's great, because then we can spend the day tomorrow on angle pairs. Because you have a test on what day? What do you need to have with you when you come to take the test? A pencil. A calculator, because if you don't have a calculator, that's it, man. Alright, ladies and gentlemen. Guys. So as this stuff is moving forward, here, now, ladies and gentlemen, what's happening here is that you have to understand what they're giving you. So when you're graphing things, you want to graph things when what is by itself? Y. So sometimes you have to move and solve the equation to get y by itself. You have to work with what's called a literal equation. You're just going to move some stuff around and get y by itself. Not a big deal. Pretty simple. Also, on that front page, it's reminding you how to graph y equals a number. When y equals a number, what kind of a line is it? it's horizontal, okay? Now, at the bottom of that page, it just talks about finding slope, which means you have to find the slope. Make that more difficult if you'd like. Then as you go through the top of this next page, there are basically two problems then for every type of way that we would write graphs, or write equations of lines. Given a slope and an intercept, given a slope and a point, given 2 points, and then write an equation of line that's parallel, or write the equation of line that's perpendicular. These problems encompass everything we have done over the past 4 days. This should not be very difficult, okay? I'm giving you guys time now. I'll just meander about, but I expect you to be working. Mindfulness and music, that's fine. If you get ahead and you get done with those and you want to start working through some of the angle pair stuff, that's fine. I'm not going to go over any angle pair stuff today. I'm going to save that for tomorrow. That's been a little bit longer to talk about. Okay, so we'll talk about those things manana. Okay? You have time now to work. Let's work. What's up?